So, so far I have already conducted a few sessions. I've At first when I first started out, I didn't record any just to make sure that everything's running smoothly. I've been starting to record, but like the audio always sounds very bad, so I've been like, trying new methods. So hopefully this is better. Okay.
Yeah, I hope it's going to be better with your record session.
Yeah. And if it is, this is going to be the first session on YouTube. We'll see. I don't know. Okay, so I got a few notices to give before we begin. The first one is that I may ask you to share your screen, and when you do, just make sure that you close anything that could be sensitive. The second one is that I limit sessions to one per week for each person, just to give other people a chance. The third one is that this isn't like an official course of a university. There's no exams, there's no tests. I won't give homework unless you want homework. So it's really tailored to you. And the
In
final thing is that I'm on the Zoom free tier, which means that after 40 minutes, the session, Zoom is going to kick us out, and I'll have to send you a new link after that.
Yeah, sure. How many hours will our session be?
So typically a session is 1 hour. Uh, I may not use the whole time, but it's at most 1 hour.
Okay.
Yeah. Okay, great. So before we begin, I also want to just understand, what are your goals and what do you hope to get out of these sessions?
Well, my goal is to learn programming. Like if we're I think you're using Python.
Uh, Pirate, which is going to transition you to Python.
Yeah. So I want to learn some the basic knowledge and other fundamental things. And I'm trying to transition into a web developer, so that is my goal.
I see. Okay. Um, I will say now that web development is pretty saturated, but you said that you're interested in learning fundamentals. I think that's good because when you learn the fundamentals, you can transition to a lot of the fields in computer science.
I see.
Yeah. Okay. Now without further ado, let's get started. So I'm gonna first start you off with Pirate, which is like it's not Python, but it there's some similarities with Python.
Okay,
I'm
okay,
gonna send
sure.
you a link, and I'd like you to open the link and share your screen with me.
Okay. Let me share the screen right now.
Yep.
You can see my screen right now, right?
Yeah, it's loading. Okay, now I can.
Yep.
Yeah.
So, wait.
And could you open up the link I sent to you on Zoom chat? Yep.
Here.
Yeah. Okay, so I'm gonna treat you like an absolute beginner, but according to the Google form, you have taken classes before, but have forgotten them all, right?
Yeah.
Okay, so in cases like this, usually when I start people off, they usually move faster than I expect. So if I see that you're moving really quickly, I might pick up the pace. But we'll see. Let's just get started first. I might change the pace. Um, so to start with, I'd like you to think of two big numbers, and I would like you to add them.
Any number, right?
Any number.
Yeah. So, like, I will go with 18 and 20. Two big
All right,
numbers.
great. Let's add them.
Yeah. Run or do I just click enter?
Well, if we want to add them, how do we add two numbers?
Plus. We use the
Okay.
plus symbol.
Okay, so I'll tell you right now, we don't actually need the equal sign. We only need the plus. So at the top right of the screen, there's a blue run button. Let's click on that to run the program. There
Oh,
we
okay,
go.
okay.
Okay, it's like a calculator, right? 18 plus
Yeah.
20, and then you hit enter, and now we get 38. Very good. Um, So right now it seems like programming is like using a calculator, which is unsurprising because a calculator is just a computer, right?
Yeah.
Okay, let's add a third number.
So
Yeah, but let's add it to the 18 plus 20 as well. Okay, let's
then
run it
I
and see what happens.
yeah,
Okay, it's pretty expected. So far, so good. Okay, could we change one of the plus signs to a minus?
like
Okay,
this.
that's
And
perfect. Yeah. Oh, what's happening here?
it's at the same group level and it needs to add a parenthesis.
Okay, so what's the problem and how do we fix it?
Um I think we need to add a parenthesis right here at the group level of the 18 plus 20, I think. And I don't know if I uh uh add the group level for the 47 though,
Okay, let's try your first thing.
like this.
Yeah, let's run it. Let's see what happens. Hmm.
Oh, nice. Okay.
Right. And yes, you are correct, actually. So the problem was that the program didn't know whether or not to do the addition first or the subtraction first. And so you had to specify it by wrapping the operation you want to happen first in parentheses. So we want to add 18 plus 20 first, add that, and then subtract it by 47. Right?
I see. I see.
Okay. So what this tells us is that there's order of operations. That one line, many things is happening in that one line, and we need to specify in what order do they happen. Right?
Okay. Yeah, right.
Are you familiar with BEDMAS or PAMDAS?
No, I don't know about those two.
Okay, so these are like in mathematics, when we use plus, minus, times, divide, there are certain operations we do first. Like if we see times, we do times first, we do multiplications first, and then we
Yeah.
do additions. Like
Yeah.
this is a convention in mathematics, right?
Yeah.
But that does not exist here. Here we need to specify it manually. We need to wrap everything in parentheses.
Oh, okay.
Okay.
S- So, what do you mean? Like we need to add like a per group level?
Yes.
Oh, okay.
Like what's in front of us here, we had to put parentheses for 18 plus 20 to say we want to do addition first.
Then what if there's like four numbers in a one line? Then we
Oh,
need to have two groups for that, right?
let's try it. Could you
Oh.
multiply another number in this line?
Uh, the multiplication is asterisk, right?
Oh, yes, yeah.
Yeah. Okay. Um.
Okay, let's see. Yeah, there we
Yep.
go. Very
Oh.
good.
Okay.
Okay. Okay, let's try something a little different. So right now it appears that like, we're using a calculator that we have to add a lot of parentheses. I would like you to delete everything in the left-hand side. Okay, and I want you to humor me for a second. I would like you to write two numbers separated by a comma.
Two numbers separated by a comma.
Yep. Okay, now surround everything in parentheses. Before the first parentheses, I would like you to write NUM dash MIN. No, MI, like M for Marvin, NIN.
Oh, okay.
Yeah. Okay, before we run it, what do you think is going to happen?
I don't actually know. So, can we run it though?
Okay, let's see. Oh,
Oh, it gets the minimum number.
The minimum, yes, min for minimum, right? But let's test a hypothesis. Can we change the first number, 29, to a bigger number?
Um,
59, great.
then I'll oh it automatically gets the minimum number in the group level.
Yeah, exactly.
Oh, okay.
Well, so just now, we saw plus, minus, and times. What we were able to do is we were able to get many numbers to get reduced to one number. But that's not surprising because those are operations that we use in mathematics. But here, this is a little bit different, right? There's no
Yeah.
symbols here. It's a word. We say num min. Give it two numbers, and it gives us the smaller one.
Okay.
Okay, so I got a theoretical question for you. How many math operations can there exist?
Um, I think it's four.
What are the four?
The plus, subtraction, multiplication, and addition. Sorry. Addition, subtraction, multiplication, and division.
But there's a fifth in front of you, right? Minimum. That's a fifth operation.
Oh, is it?
Yeah, it's a operation. It's like operation as in like a thing you're doing on numbers, right? You're doing stuff
Uh,
to the numbers there.
yeah. So it's for if the minimum is the one of the operations, then maximum is also one of the math operations.
Yeah,
Mean so there is a lot of math operations except
a lot.
those. Yeah. Oh,
Can there
okay.
can there be a limit? Can we always add more math operations?
Um, if it's I think if it's acceptable to the program, I think.
Hmm. So what this means is that there can be an infinity of math operations, right? We can always have
Yeah,
more,
yeah,
but we only have a limited number of symbols, like plus, minus, asterisk. There are only so many symbols we can use.
yeah.
And so we need words. We need words to name our math operations, like num min.
Okay.
All right. Let's try something. Can we add this whole thing to another number?
Add.
Yeah.
Okay. So should I go like this
Yep.
and then should I use the numbing or just number?
Oh, just a number is fine. Okay. Let's run it. Let's see. Ah,
As so it adds to the 40.
exactly. Yeah.
Mm, okay.
Okay. Now I would like you to highlight plus 12.
Then
Including the plus.
okay.
Yep. And I would like to cut it and paste it next to the 40. Actually, wait, no. I changed my mind. Can you control Z? Can you paste it next to the 59? And can you make 40 a bigger number? Okay,
Yes.
let's run it.
Oh, okay. So it adds to the 59, whether it's outside the group or inside the group.
Okay. There is a subtle difference that is not obvious here, which is that the addition happens first before the comparison.
Mm, okay. So if
Uh,
it's
yeah.
outside the group, it will compare first.
Yes.
Oh, I see.
So it's back to order of operations, right? Remember how I said that, the parentheses happen first?
Yeah.
Okay, the parentheses are like, right, you see it, the parentheses are there.
Yes.
Yeah. Okay. But anyway, all this is to also show you that these ideas, the num, min, plus, minus, all they can mix and match, right?
Yep.
We're doing addition and we're doing comparison at the same time.
Yes.
Yeah. Okay. So far we're really exploring the laws of arithmetic, but with a computer. That's what we've been doing. But we're going to move a little bit beyond arithmetic and we're going to move into algebra, right? It's like we're going through middle school math right now. And one important in algebra is the use of variables. And so we're going to do that. Could you delete everything? Okay, right? X equals 1, new line, X. Okay, if we run it, what do you think will happen?
I think it will display the value of x.
Which is?
1.
Okay, let's run it.
Yep.
Okay, can we change X into X plus 1?
This at the last line or the first
Yes.
line? Okay.
Second line. Yeah. All right, let's run it. Let's see what happens.
Oh, then it adds the 1 to the value of x, which is 1. So it is equals to 2.
Exactly. Yes. So whenever we see X, we see 1, right? Variable
Yeah.
substitution. Okay, great. Okay. On line 2, can you create a new line? Oh, before that line.
Oh.
Yep. And I would like you to write X equals 2. Okay, before we run it, what do you think will happen?
I think it will change the value of x. So the first one is it will be 1, and we declare it a new variable as uh 2 into the x.
That's a very good guess. Let's run it. Let's see what happens.
Yeah.
Ah.
Of name conflicts with an earlier of the same name. What?
Hmm. Okay. So in some programming languages, like Python, for example,
Yeah.
what you say would have been correct. But different programming languages have different takes on this. In this programming language, you can't do this. Why?
Oh, okay.
It's because like if you're a mathematician, you're writing down like mathematics, like let x be 1, and then you write let x be 2. That doesn't make sense, right? It's like you already said x is 1. Why would you change it?
Okay, I see. I see the point.
Yeah. Again, yeah, different programming languages do things differently. So that equal sign is a declaration by saying x is 1. That's what declaration means. Like we're declaring something. And the moment you declare something, you're saying it's that and not anything else. And so if you're trying to say, oh, x is 1, and you declare x is 2, it's going to be like, oh, you already declared it just now. Why are you doing it again? Doesn't make sense.
Yeah.
Okay. But we are going to revisit this idea in the future. We'll see. Anyway, let's change x equals 2 into y equals 2. And let's change x plus 1 into x plus y. Oh, can you change the 1 to x?
Oh, okay.
So we're adding the two variables together. If we run it, what do you think is going to happen?
Um, it will show the result of 1 plus 2, which is equals 3.
Okay, let's run it. Let's see.
Yep.
Ah, nice.
Okay.
Okay. So we explored important idea in algebra, which is variables, and we're going to explore another idea. We're going to explore functions. So in mathematics, we can say something like f of x equals x, right?
F of x is equals x.
In mathematics,
Yeah.
yeah. And we're going to do something similar here, but it's going to look quite a bit different. I want you to delete everything. Okay, and I want you to humor me for a second. Right? fun space f opening parentheses x closing parentheses colon new line x plus 1 new line end. D. D for donkey. And I think they have to be lowercase. So lowercase n. Very good.
Oh, okay.
Oh, notice how it's highlighted, lines 2 to
Yeah.
4. What we have done is we have just defined a function. So the fun and end, they're keywords. That's why they're bolded. When we say fun, we're saying we want to define a function. So a function has three parts. The first is a function has a name. It's called f. So when we want to refer to that, so the same way that variables have names, functions also have names. So that's the
Yeah.
first part, the name. The second part is the parameters. So parameters, they're like variables, but inputs to that function. So we can pass functions are like inputs and outputs. You give it stuff, it gives you back stuff. So it has an x. Whatever you give it will be. I'll explain that in a moment. And that's the second part, parameters, which are like variables for that function. The third part is the body. This is the body of the function. X plus 1 is the body.
Okay.
Now we need to say end to say when does the function end. What is the end of the body? Okay.
Yeah.
Okay. Can you click run? And we'll see. Oh wait. Oh yeah. What's happening here?
It must have what's white space.
Okay. So not all programming languages require that, but this one does. So, every programming language is a little bit different. Okay, very nice.
Yeah.
So we ran it and nothing happened. Uh, so the reason why nothing happened is because we didn't use the function. We only defined it. Let's create a new line and let's apply the function. So in mathematical speak, when we want to use a function, we say we apply the function. And so let's do f, opening parentheses, and any number you want.
Oh, okay.
Yeah, 17.
17.
Okay. All right. We got back 18. Why do we get back 18?
So it's like uh we call the function and input a number. So the 17. So the the value the x has a value of 17. So that's why 17 plus 1 is equals to 18.
Very good. Yeah. So it's again the idea of variable substitution, right?
Yeah.
Where x is a so quote unquote variable.
Yeah.
Okay. Okay, this is very much similar to middle school mathematics. We're going to try something a little bit different. Notice how there are two windows in front of you. The one on the left is what we've been editing. The one on the right has been giving us answers, right?
Yeah.
Okay. I want you to click the window on the right. I want you to write F, opening parentheses, and any number you want. And then I want you to hit enter.
Oh, okay.
Okay. So the window on the right, it's sort of like you can write one-line programs and get an answer immediately. Okay. Now, notice how we didn't touch the program on the left, but we got a new number.
I have a question. So
Yes.
it's like this is applicable for if I have a function in my on the left side, right? Or does it apply to like the first session, like our at the first part where x plus 1 equals 2?
X plus 1 equals 2.
Yeah, so like if I use this uh 1, then
Oh,
x plus 1, then it will I will write this like 5. Is
let's
it
try it.
applicable
Let's try
here?
it.
Oh, okay, I see.
No, I'm not saying yes or no. I'm saying try it first.
Oh, okay.
Okay, let's try it.
um
Okay, so you need to run the program again. Whenever you modify the program, you must run it again. Okay,
okay.
now let's do it. Oh no, you have to click enter.
Ay,
Yeah,
sorry,
so when you
sorry.
use, yeah, no, it's okay. Yeah, you have to hit enter.
Okay.
So you're correct. So you asked a very good question. Like it works on functions, does it work on variables? And the answer is yes.
Mm, okay.
Okay, so I got some explaining to do. So the left-hand window, we call it the definitions window. This is where you define your program. whenever you define stuff and you click run, the right window will maintain those definitions. It will know those definitions. So we define f, we define x, it will know those two things. Yes?
Yeah.
Okay. So we call this the REPL. REPL. Four letters. R stands for read. It reads what you write. E stands for evaluate. In mathematics, evaluate means to like simplify, right? Like
Yeah.
1 plus 1 is 2. We're evaluating 1 plus 1 to 2. Uh, P is print. After it computes the answer, it prints it out. So we see 6. L is loop. Loop because you can keep doing this again and again. So a REPL is useful for very fast iterative feedback. You can keep making changes and you can like get answers very quickly. You don't even have to press run, you just hit enter, right?
Yeah.
So not all languages have this. This language has it because a REPL is very good for learning, and this language is designed for beginners. It's designed for people to learn quickly. Okay.
Okay, I see.
Yeah, so like at your own time, outside of these sessions if you like, I encourage you to play around with this and you can learn very quickly.
Yeah, sure. I'm gonna play around with this, like the function and you know, even though my head's hurting a little bit.
Yeah. This is only the beginning, man. This is only the
Oh no,
beginning.
oh no, oh no.
Hmm.
Yeah.
Okay.
Uh,
All right. So far, just to summarize, we have basically done algebra, arithmetic and algebra, but with a computer. Okay.
yeah.
So that's fun. But I'm going to start transitioning into something more than this. So the first thing I want you to do now is I want you to delete the entire program. And I want you to write a number 5. And I would like you to run it.
Yep, it displays
For
5.
now, nothing interesting, right? We write
Yeah.
in 5, we run it, we get back 5.
Yeah.
Okay. Now, I got a question for you. What does 5 mean?
Like it's a number.
It's a number.
Yeah.
That's it. 5 is a number.
Yeah, I think it's a number. I mean, I actually, yeah, I know it's a number. Oh man, what
Okay.
what
Okay.
the
Okay, I admire your confidence in what
yeah.
you believe in. Okay. Okay, 5 is a number. Great. Okay, now let me change the question a little bit. What is 5 degrees Celsius?
Um, it's a temperature.
Temperature, right? How hot,
Yeah.
how cold something is. Okay. What if I say 5 kilograms? Then what does it mean?
It defines the weight.
Weight.
Yeah.
Okay. How heavy, how light something is. Okay.
Yeah.
Now, in all of this, they're all 5, right?
Yeah. Right.
But depending if whether I say 5 degrees Celsius or 5 kilograms, it means something a little bit different, right?
Yeah.
Okay.
Yeah.
So all this is to say is that there are two worlds. There is the world of information. These are facts about the world, ideas about the real world. 5 kilograms, 5 degrees Celsius. And there's also the world of data. 5. This is what the computer sees.
Oh, I
When
see.
the computer sees that 5, it doesn't know if it's temperature or kilograms. It just sees 5.
Right.
That's
Yeah.
data. Yeah?
Yeah.
Okay, so this might sound philosophical, but it's a very practical idea, and it's going to be the foundations of everything that we'll do in these sessions. Our job as a programmer is to facilitate the interaction between the world of information and the world of data. We turn information into data. When like 5 degrees Celsius, we write 5, the computer knows 5. We turn information into data. We call this encoding. We encode
Encoding.
information into data. You might also hear the word representing. We represent 5 degrees Celsius as the number 5 in the program. And
Okay.
what we can do as humans is we can decode data back into information. For example, if you look at that 5 with your human eyes, you think, oh, 5 degrees Celsius. We turn data back into information, right?
Oh, I see. Yeah.
For example, when you submit the Google Forms, when you sign up for this office hours, I ask for your name, I ask like, do you agree to these terms and whatnot? All of that is information. Like your name is information. Right. The session guidelines are all information, but then when you submit the form, they became data. They became things in a spread. So like when you submit the form, I see it in a spreadsheet. So like they're data in my spreadsheet now, right?
Yeah, right.
And then later, like when I want to start the meeting with you, it's like, oh, what's this person's name? I go back to the spreadsheet, and then I can see, oh, I can see the data that's your name, and I get back the information. Oh, that's the person's name. Data becomes information again, right?
Yeah. Yeah.
Okay. So
So
yeah,
like we lock in all the numbers like the datas in the program. Then when it comes to outbound like 5, it will convert to information.
exactly. Yeah. And as
Yeah.
humans, we do this naturally, right? When you read the number five and I tell you its temperature, you're like, oh, 5 degrees Celsius. Yeah.
Yeah.
Okay.
Oh, I see. I see.
Okay. Now I have a somewhat philosophical question for you again. Right now, we can encode information as numbers. That's what we have been doing. We've been encoding information as numbers. We've been working with numbers. Can we encode all information as numbers?
Can we code all information as numbers?
Yeah.
I mean, no. I
Okay.
mean,
Why do you
yeah.
say no?
Yeah. We could encode all information into numbers, but it's based off what kind of information.
Can you give me an example?
Like so like if there's um we could say like there are 5 people and they talk all about their age. So we could encode all of their age into numbers. But what if something like kilograms? So I think it's in another category.
Hmm. That's a good answer. But I have a argument against that, a counter argument.
Yeah, sure.
Have you ever heard that computers are just zeros and ones?
Yeah, zero and ones.
Yeah, fundamentally zeros and ones, right?
Yeah.
Aren't zeros and ones just numbers?
Yeah. I mean the
Hmm.
it shows the true or false through the true and zero and ones, right?
Yes.
Yeah.
Okay. So so this is very theoretical, but the idea here is that everything can be just numbers, right? That's what computers fundamentally are. True and
Yes.
false signals in circuitry, right?
Yes.
Okay, but next question. Do we want to encode all information as numbers?
Yeah. Yeah, I think so.
You want to encode all information as numbers.
Yeah.
Okay, so like right now, I'm speaking to you with language. I'm speaking with you in words, but do you want me to speak to you in Morse code? Like beep boop boop beep boop beep.
uh, I mean, no, because we're in the information world. You know, bro, my mind is like literally scattered. Like
Okay, that's okay.
my brain's literally
No, no, okay, there is no right answer here.
Yeah,
But what I'm trying to get to is that there are limits to the usefulness of numbers, right? Like when I'm
yeah,
speaking to you, I'm I'm like language. What is language, right? Language, we're encoding information into words. Like when I say banana, you have a picture of banana in your brain, right? You're thinking of a banana. But how did I send that idea to you? I said the words banana.
yeah,
Banana is not a number, right?
yeah,
As you say, it's a different category. It's something else. Banana is a word.
yeah,
Okay. So, okay. You know how they say like the universe is just like particles?
yep,
So, in front of me, there's a table. I see a table, but what does the universe see? The universe sees particles, right?
Yeah.
I don't see it as particles. I see it as a table.
Yeah, you see it as an object, right?
Exactly. So what I'm saying is, even though we can encode all information as numbers, we don't want to do that. That's like very hard to understand. We have to turn data back into information, right? Like if I'm seeing a bunch of numbers, like that's not useful to me.
Yeah, I see. I see your point. Yeah.
We need new ways to encode information that would be useful to us. And so right now we're gonna get back to programming. I'm gonna introduce a new way. I would like you to delete everything. I'll delete that five. I would like you to write double quotes. Hello, comma space world. Oh, you must add a comma after the O. You must. I'll explain why in a moment. Okay, let's click run. String. We call this. So notice how we didn't get back a number. We got back something different. We got back something in quotes. Hello
Yeah.
world. This is a string. I think it's called that because it's like a string of characters. So the reason why I asked you to write this is because there's a book, I believe in the 70s, teaching people how to program. Back then they didn't have Python, they used C, a very low level language. Um, and the book used the example Hello World. And ever since that day, every book, every tutorial, every video course that ever exists uses this Hello World.
Hello world. Yeah.
This is sort of like a rite of passage, a milestone in your learning journey. You have to write this.
Yeah. Like it's a ritual, right?
Exactly, yeah.
Yeah.
Um, but a lot of people they drop the comma, but the original example had a comma. So I always tell people you must write
Oh,
the comma.
okay, okay. So like it's like the
Oh,
OG rule.
exactly, yeah. You're one of the real ones.
Yeah. Real ones.
Okay, so right now just now we had numbers, now we have strings. This is a new way of encoding information. We encode information as a string. It's not a number. Now underneath it may be zeros and ones, but for our purposes, we as programmers, we treat this as a string. We see a string in front of us, right?
Yeah.
Okay. So this Zoom session is gonna expire because I'm on the free tier. I'm gonna send you a new link on email, okay?
Yeah, no problem. Yeah.
Okay, check
Sure.
your email, okay? I'll see you in like a minute.
Okay.
Hello, welcome back.
Yeah. Well,
Okay,
hi again.
yeah. If you could share your screen with me again.
Yeah.
So
Did
yeah,
you
Zoom
see?
will never get my money. Yeah, it's loading in a moment.
Yeah, okay.
Okay, I see it now. Okay, great. Um, could you okay, yeah, so we see a string in front of us. Just now, we saw numbers and we did stuff with numbers. Could we do stuff with strings? Is there arithmetic for strings? Could you add that string to another string?
So like I'm gonna go like this.
Sure. Okay, no, I added the space. Okay, that's smart.
Really? Is it
All right, yeah, let's run it. Okay. Hello world again. Okay, okay, this is smart. Okay, a lot of people they add a word but they don't add the space. So
Oh,
like
okay,
the
I see.
okay, okay, but I think because you added the space, I know that you knew this was gonna happen, right? You knew it was just gonna
Yeah,
join two strings together. Okay.
yeah.
Um, so just like we can add numbers, we can add strings. There is arithmetic for strings. Could we change the plus sign to a minus?
Uh,
Okay, let's run it. Let's see what happens. Oh, what's happening here?
Two numbers?
It expects two numbers. The minus operator expects to be given two numbers. So we cannot subtract strings, right?
Yeah.
So what's interesting is we can add two strings, but we can't subtract them. I mean, it doesn't make sense. Like, what does it mean to subtract two strings?
I mean, yeah, because we literally add a string.
Yeah. So the operations for numbers and strings are different.
Hmm.
Okay.
Is it possible if ano, if it's multiplication?
Let's try it.
I think it would go wrong.
Ah,
Yeah.
okay.
It's expects two numbers.
But it's good to ask these questions, like, oh, like, does it make sense to do this?
Yeah.
Okay, I'll show you an experiment. Can you change the string again into the number, any number?
The string?
Yeah, again, the string again.
Okay.
Okay, yeah, that works too, yeah. 41, yeah. But can you change the 41 to be after again? So swap the order.
After again,
Yeah. Like, so again, multiply 41. Wait, no, no, no. The string again times 41.
the string again tas times 41,
41.
right?
Yeah. Yeah, yeah. Okay, run it. Okay, it doesn't make sense, right?
Yeah.
Okay, in some languages, that will repeat again 41 times.
Yeah.
So every language is a little bit different. Some languages will do that. So sometimes you might think like, oh, that doesn't make sense. But sometimes you should just try it because you never know. Some languages actually this will work for some languages.
Yeah.
Okay. All right. Okay, let's delete everything. And I want you to write double quotes 5 and run it. Okay, we get back 5 in quotes, which is not surprising. We wrote a string just now, we got back a string, we write string like 5 inside the string, we get back 5 inside the string, which makes sense. Okay,
Yeah.
could you go back to the program and can we add a new line and just write that number 5? No, no quotes. And let's run it. Okay,
So it's a number.
it's an actual number, right?
Yeah.
Okay, so we see two versions here. Okay, now let me ask you. Now that we have strings, and strings are a series of characters, and in order to write a number, we need to write a series of characters. Why do we need numbers? Why can't we make everything strings?
Um, because if you but because if it's all about string characters, then I think we would have a problem with uh adding or computing real data numbers.
Okay, that's a good
So
answer. Yeah,
yeah, it's like we need for every program we need a computation method.
it's a very good answer. Yeah. It's like subtraction, right? We can
Yeah,
subtract two numbers, but we can't subtract two strings.
yeah,
Adding means something completely different from strings than to numbers.
right.
Yeah? Okay. So while the same piece of information can be represented with multiple data types, like the information like 5, we can put inside a string or we can it be a real number. There are strengths and weaknesses to each representation. So remember how I said our job as a programmer is to facilitate the interaction between the world of information and the world of data?
Yeah,
So this is an example of that. As a programmer, we need to choose which representation is best for that information. If we expect to do like math computations on like temperature, then we should store it as a number, right?
yeah,
Yeah. Okay. So just to summarize, we have explored two data types. So like these are two categories of data, right? Two classifications of data. We call them data type. We saw number and we saw strings. I'm going to introduce a third one. So the whole idea of data types is that they're encoding some kind of information and they're easy to work with. And there's one information in life that is very important. It can be said that life is a series of decisions, and a decision is fundamentally a yes or no. For example, your decision to come to this office hours, you have said yes, right?
yeah,
And so it would be really useful if you have a data type to encode decisions. I mean, computers are all about making decisions, so it sounds like a very important idea.
yeah. That's
Uh,
right.
so this idea, this very fundamental idea, yes, no, on, off, right, wrong, true, false, the idea of dualities, We call this data type booleans. And in computer science and in like most languages, this is true and false. They're called booleans because they're named after a person named George Boole. He's a person that studied these as mathematical objects. So I'd like you to delete everything and write the word true, true, and let's run it. Get back true. Notice how the true is red in color. It's a keyword. It's special. Now let's delete
Yeah.
that and let's write false. And run it, we see false. Okay, great. Um, Now I want you to write false or true. That's or.
Caps lock or small letter?
Yep. Small letter. That's perfect.
Yeah.
So notice how the or is bolded. It's a
Yeah.
special keyword as well as a special operator. If we run it, we'll see something. False or true. Notice how we have two booleans and we reduced it to one. You get
Yeah.
that true. Okay. So we call them boolean. Oh, actually, I'll show you one more. Can we change the or into n, a, and d? Okay, let's run it. False and true is false. Okay. We call the thing in the middle, the and or, we call them Boolean operators because they operate on Booleans. We can reduce multiple Booleans into one Boolean. So this is like arithmetic for Booleans. The same way we can add numbers, we can add strings, we can add Booleans together. Right.
Oh,
I'm going to
like,
show you something and I'm going to share my screen in a moment.
okay.
Give me 1 second. Uh, Give me 1 second. Okay, I found it. So keep sharing your screen. I'm just gonna share my screen momentarily. Okay, do you see what I'm showing on my screen?
Yeah.
Okay, so right in front of us is a truth table. Um, so 0 is false, 1 is true.
Okay. Yeah, I
This
see it.
tells us, so like 1 is false and true all false or true true. This table tells us the answer. So like 0 and 1 is 0 for n, 0 and 1 is 1 for or is true. So why are they like that? The short answer is that's just the way they are. The long answer is that these are all the ways that 0 and 1s can compute to the answer, and we assign names to each possible outcome. So for example, like 0, 0, 0, 1, 0, 0, 0, 1, 0, 1, 1 is 1, we call it n. Why do we say it's n? If I ask you, do you have an apple and banana? And you have both of them, you say, yes, I have an apple and banana. But let's say you have an apple, but you don't have a banana. I say, do you have an apple and a banana? You say, no, I only have an apple, so it's false.
I
For
see.
true, for or, if I say, if you have an apple, but you don't have a banana, I say, okay, do you have an apple or a banana? You say, yes, I have an apple. But if you don't have an apple and you don't have a banana, I say, do you have an apple or banana? You say, no, I do not have either of them. It's false,
Oh, I
right?
see. Yeah.
Um, so that I mean that's roughly why they named it that. Honestly, the names are arbitrary. Uh, Remember how I said that computers are zeros and ones?
Yeah.
These are the zeros and ones.
Okay.
These over here on top of them, you see these shapes. These are logic gates. These are like very, very tiny physical objects, and we can have hundreds, thousands, millions, billions of them. We put them together, and we can make computers. The computers are made with these things.
Yeah.
There's all these zeros and ones inside of them, and these logic gates, these Boolean operators, they reduce zeros and ones into more zeros and ones. And this is why there's computation. This is why computation is possible. Now, these zeros and ones, they might be numbers, they might be strings, but this is like the universe, right? This is like the universe. This universe is made of zeros and ones. It's operating as zeros and ones. As programmers, we see more than zeros and ones. We see strings, we see numbers. Anyway, you don't need to know this. I'm just showing you that there's arithmetic for Booleans, and these are done with Boolean operators. And these are just some examples of Boolean operators. You don't need to know most of them. You only need to know three. You need to know not, and or.
Okay.
Unless you are an electrical engineer or in cybersecurity, you only need to know those three things.
Okay.
Okay. So I'm going to stop sharing my screen now. And let's get back to your screen. Okay. So that's booleans. So we have seen number strings and booleans. These three things, number strings and booleans, are like your cache. If you're lost in a city and you have cache, you can probably get what you need. If you have information and you need to encode them, you're probably going to use one or more of number strings and booleans.
Okay. But I
Okay.
have a question though.
Yep.
So, is it possible to have like in this logic we have the false and true, right?
Uh-huh.
Do is it possible to have like multiple logic cases of true and false, like true or false?
Let's try it.
Oh, really?
Let's try it. No, I'm not saying yes or no. I'm saying let's try it.
Uh okay. I thought that's a yes.
When I say let's try it, it means I'm not telling you. You must find out on your own.
I mean, how should I put this?
So false and true is one boolean. True or false is going to provide another boolean, right? So this
Yeah,
we have four booleans. Then we reduce them into two booleans.
yeah.
What do we do with two booleans?
Um, the true and false, or this whole no.
Yeah, this whole thing, right? Notice how you
Yeah,
got two parentheses, but there's nothing in between the parentheses.
yeah. The in between.
Yeah, yeah.
So the should I add an operator or?
If you want to keep down the same line, you must. Yeah.
Oh, okay. So if I add plus,
Oh, okay. Let's see.
the left side was false, the right side was true, or two strings. Yeah, two numbers or two strings.
So
So
what
it doesn't
operator works on
apply.
booleans?
Um, is it end?
Okay, yeah, that's a boolean operator. Yeah, that's right. Ah,
Huh? Wait, why?
okay. What's false and true?
Uh, this one is false, while
Okay,
this one is true.
okay. What's
So
false
if
and true?
false, false, yeah.
Okay, okay. So yeah, I like you that you're asking questions. So it's very important as programmers, and I think it's an important thing in life that you always ask questions, be
Okay,
curious. And with programming, the good thing about programming is it's very easy, it's very cheap to run programs. At least now. Back then it used to be difficult, but now it's easy. So if you have a question, just try it. You'll
okay,
learn something.
sure. My brain is really hurting right now. I
Okay, now that's good. That means
uh
when you wake up tomorrow, your brain will be stronger. It's like exercise, right? When you exercise, you tear your muscles, and then the next day your
yeah,
muscles are stronger.
yeah. But it's a, like it's a I like the challenge that it keeps me racking my brain out.
That's good. Okay, I want to show you one final thing, and then let's wrap up. Give me 1 second. Let's see. I'm gonna type something in Zoom chat, and I'd like you to paste it in. Okay, just copy that and paste it into the left window. And before you run it, I want you to ask you what's gonna happen.
So
Ah,
it displays a red circle.
yes. In this language, that's another data type, images. Now, a data type doesn't have to be fundamentally philosophical. A data type could just be useful. This language is designed for beginners, and many beginners are children. And like it's fun to work with images, right? And so images are a data type in this language. Okay. So let's wrap up here. One thing I like to end my sessions with my students is I like to ask them, what's one thing you learned today that stuck with you?
Um, I think it's the the universe see it as particles, but we humans see it as objects.
Excellent.
Yeah,
Okay. All right. So,
that's how like it presents our real world into datas.
mm, yeah, excellent. Okay. Um, so there's no homework unless you want homework. If you want homework, I'll give you a lot of homework, man. Um,
I mean,
so
you
yeah,
could try. I mean, I do my homework.
wait, you do mind homework or you don't mind homework?
I mean, I do mind the homework. It's like pr it's kind of prac like a kind of practice, so I won't
Okay.
forget the lessons you provide.
Okay. I will
Yeah,
email you something, and if you have time, you can work on it, but no pressure if not. Again, this is like this, the pace that you progress is completely up to you. Okay, I
yeah,
do have
sure.
to wrap up now for my next session. Um, you know, Thank you for joining me in my office hours.
Yeah, thank
I'm
you.
glad you learned something today, and I hope to see you again.
Yeah, thank you for teaching me. Thank you, thank
No
you.
problem, man. All right, bye-bye now.